Hello everyone and welcome to today's programming video. In today's video we will solve the Leetcode problem to find the largest local values in a matrix. Let's have a look at the problem statement. We've been given a two-dimensional integer array called grid, and the size of the grid is n by n, which means it has got same number of elements on the x and y axis. And we've been asked to generate another integer matrix called max local, and its size is equal to n minus 2 times n minus 2. That means that if your grid is of size 4 by 4, then your resulting output grid or output matrix will be of size 2 by 2. And let's have a look at what values we need to put in that resulting matrix. For that, let's have a look at the example which has been provided. If you look at this example, we need to find the resulting matrix, which has to be of size 2 by 2 because the input grid is of size 4 by 4. Essentially, we need to find the largest values in each 3 by 3 contiguous arrays. So what does that mean? So the first 3 by 3 matrix will be this one. Okay. And then the next 3 by 3 matrix is this. Now let's look at these two examples first. In the first case, the largest value in this matrix, the 3 by 3 matrix, the red colored one, is 9. And if we look at the start position of this 3 by 3 matrix, so it's 0, 0. If you look at the green colored one, it's 0, 1. Okay, so what does this mean? So if you look at this 3 by 3 matrix at position 0, 0 and look at the largest value, which is 9, is to be stored in the resulting matrix at position 0, 0, which is why it's here 0, 0, 9. Okay. Now look at the green colored 3 by 3 array, and its position is 0, 1, so the position of the first element in the 3 by 3 array is 0, 1, and the largest value in this 3 by 3 matrix is 9, and therefore we store 9 at 0, 1. Now let's look at the third 3 by 3 matrix. It starts here. Okay, and what's the position of the first element here? It's actually 1, 0. And what's the largest value? Is 8 here. So we want to store 8 at position 1, 0 in the resulting matrix. So 1, 0 contains an 8. Finally, the last one, we can say that its position, or the start position, or the position of the first element in the 3 by 3 matrix is 1, 1, and the largest value is 6. So let's just say this one. So 1, 1, we store a 6 there. Okay, so to solve this problem, we'll essentially have to loop through this entire grid, and for every inside of every loop, we need to check our 3 by 3 matrix and then find the largest value inside of that 3 by 3 matrix. So what I mean is, let's say we say I and j as our values to iterate to this grid. So I and j. Okay, so what are the values for I that we can have? I can go from 0, 1, and that's it. You can't go any further because beyond that you can't get any 3 by 3 grid. Similarly, j can go from 0 to 1. You can't go to 2 because there you won't get a 3 by 3 grid. So essentially I can go from 0 to the length of the grid, if you call it that, minus 2. Similarly, j can go from 0 to the length of the grid minus 2. Now, for every value of I and j, we have to mark our 3 by 3 grid. So let's say I and j are 0, 0. Then we are looking at this red colored grid here. And now that's a 3 by 3 matrix. Now, to find the largest value in a matrix in general, we need to have two loops. One which goes from 0 till the number of one-dimensional arrays, and inside of each loop there's another loop which checks every element inside of each one-dimensional array. So that is a standard for loop inside a for loop. So that means that we'll need essentially 4 for loops to find the solution to this problem. Okay, so let's see what values or what are the boundaries for our indices for this inner for loops. So as we saw for the outer ones, it will go from 0 till n minus 1, or length of the grid minus 2, and for the inner ones, essentially the iteration happens 3 times. So the outer one happens 3 times, the inner one happens 3 times, because the inner matrix has to be of size 3 by 3. Firstly, let's define the boundary for the outermost for loops. So this is equivalent to the n minus 2 that we have here. And now let's define our result matrix, which is also a 2-dimensional matrix. And the size of this 2-dimensional matrix will be the n minus 2 times n minus 2. Okay, now let's loop through our grid itself, and remember that the outer indices I, j will go from 0 till the grid length minus 2. Okay, now we want to loop through the inner 3 by 3 matrices. Let's go back to this diagram here. Again, if you look at the values of I and j, let's say 0, 0 again, we can see that the inner loop for the first index for the inner loop will start with at value I, and go up till I plus 2, and the inner j index, or the second inner index, will go from the value j till it is equal to j plus 2, which is actually like 3 positions. Okay, now let's make a simple start and then we can optimize it. So let's say we want to find the largest value inside of this 3 by 3 matrix. Define a variable called maximum, and let's just initialize it to the initial value of I and j. Okay, now if the current value we are iterating is larger than max, then we'll set max equal to that value. So that means we're just finding, in this loop, we're just simply finding the largest value in the inner 3 by 3 grid. And once we've done that, we'll just say result I, j So this way, what we're doing here is we're saying that, okay, in this grid, the red colored one, matrix 3 by 3 matrix, I'm finding the largest value, and where do I need to set it? I need to set it at position 0, 0, and I'm just simply setting it there. So then I move on to the next j. So j becomes 1 here, and it is still less than the grid length minus 2, which is len here. And so that means I'm going on to this green colored 3 by 3 matrix, and then I'm finding the largest value, and I'm simply setting it at index 0, 1 in the resulting matrix here. So that's how I do the looping, and it will continue till it has exhausted all the index values. And finally, we want to return our result, which is the max local two-dimensional array. Okay, let's quickly run this, see if there is any problems, compilation errors. Okay, there is one. I just forgot the semicolon. That's no big deal. It's right now. Okay, that looks good. Let's just try the sample test cases that we have. Okay, that is good, and I'm happy with that. If you wanted to optimize this further and you didn't want to use a max variable, you could get rid of this condition, and you could do something like this. So, set this equal to the maximum between the current value of result I, j and your value in the grid at position I inner and j inner. It doesn't make much difference, but it's personal preference. You can choose one way or the other. It doesn't matter. Yeah, that looks good. Thank you very much for watching, and I hope you found this video useful. Please remember to like and subscribe. Thank you. Bye.